Hello YouTube, this is Eli, the OBD Tech. I'm here working on a 2001 Honda Odyssey with a 3.5 liter engine. This video is going to be based on diagnosing a P0420 catalyst system efficiency below threshold. I'll be using three methods. First one will be using a scan tool and looking at the upstream and downstream O2 sensors. Method number two, I'll be using an infrared laser beam, and the third method will be using a back pressure tester and looking at the back pressure to see if the back pressure is within spec. And then the reason that the vehicle came to me is because a customer took it to a muffler shop and they told him that the catalytic converter needed to get replaced. So he brought it to me just to verify that the catalytic converter was indeed bad. Alright, so let me show you the code. It has one code stored. It's a P0420 bank 1 catalyst below threshold. Alright, so pretty much for this test that I'm going to perform, which is method number one, is by using the scan tool. I'm going to set up the scan tool on the generic side. I'll be actually graphing those two sensors, the upstream and downstream O2 sensors. So I'm going to start the engine now. The engine's it's not cold, but it's in a temperature range where it's kind of warm. So during open loop, your O2 sensors will not operate until the vehicle goes into closed loop. The downstream O2 sensor has it's a 1.275 volt bias line. So as soon as the heater starts to warm up, that voltage should drop to normal between the 0 to 1 voltage range. So right now the only one that's actually doing something is the upstream O2 sensor. So as soon as the heater circuit starts to warm up on the downstream O2 sensor, that voltage should drop to normal between 0 and 1. And the way I go about these diagnoses with the scan tool, I let it idle until it gets to its operating temperature, up to about 176 degrees Fahrenheit on the cooling temperature sensor. Usually the downstream O2 sensor, once it starts to operate, sometimes it will mimic the upstream O2 sensor. So as the downstream O2 sensor gets warm and hot, the fluctuation should get a little bit more steady, with very minimal fluctuation. So for now, the downstream O2 sensor is starting to go into its normal range between 0 and 1 volts. So as the upstream O2 sensor gets warmer, it will start to give you actually a signal. So right now it's in the rich condition range, above 0.45. Anything below the 450 millivolts is considered to be lean. So as the engine gets warmer and the O2 sensor gets starts to get hotter, these sensors are, this downstream O2 sensor should operate more normally. But like I said, a downstream O2 sensor that starts to mimic the upstream O2 sensor, once it warms up and gets to its normal operating temperature, it should be within a minimal range of fluctuation. Like I said, during a cold startup, it is normal for the downstream O2 sensor to fluctuate like the upstream O2 sensor, but once it gets to its operating temperature, that fluctuation should minimize and be very minimal. Just by looking at these two readings on the upstream and downstream O2 sensors, so far is looking normal. The upstream O2 sensor is switching from rich to lean, which is good. The downstream is it's kind of it is fluctuating minimal. So the next step, I'm going to do is to rev the engine about 2,000 RPM to help the O2 sensor get hotter. So here we go. I'm going to raise it to 2,000 and keep it there for about a minute or so. And let's watch our readings. So I'm at about 2,000 RPM right now. Our voltage is above 0.450 millivolts. It's in the rich condition signal. So as you can see, at 2,000 RPM, our downstream O2 sensor is fluctuating, but it's fluctuating in the rich condition, not like from rich to lean. This method number one is not really a 100% prove method of using, because there's always variables. But at least it gives you some type of direction, whether your catalytic is really starting to go bad or if it's really bad. So right now our signal went down to the lean condition, below the 0.450 below that 0.450 volts, which is below 450 millivolts. But as you can see, it's a steady lean condition signal. It's not really fluctuating from rich to lean, which is also good. So as soon as you see a downstream O2 sensor start to fluctuate or mimic the upstream O2 sensor, that's pretty much an indication that your catalytic converter is starting to go bad. I'm gonna let go of the gas pedal and go back to idle. Our signal went back to rich, as you can see in our downstream O2 sensor. So far, the downstream O2 sensor hasn't been, it hasn't been behaving like the upstream O2 sensor. So for now, just by using the scan tool pits of the upstream downstream O2 sensor, I'll say that the catalytic converter for now is showing that it's working properly. If you think about it, it's a 2001 Honda Odyssey and we're in 2019 already. This vehicle is 18 years old, so you know there's a potential that this catalytic converter may show signs of aging and starting to of not working properly no more. So far, you know, just by looking at this data, this catalytic converter is working properly. Like I said, as soon as the catalytic converter gets hot, the O2 sensor gets hot, this voltage just remains steady with very minimal fluctuations. So I'll say by using this method number one, by using the scan tool and looking at the O2 sensor data, I'll say that for now this catalytic converter is working properly. Maybe this is a intermittent P0420. Maybe there's during at times this catalytic converter is not working to its efficiency, and that's the reason why this code is being triggered. Because the customer does say that the light does come on, and then there's times where it goes out. So if the computer is seeing that the catalytic converter is working properly at its present moment, it will turn off the check engine light. Alright, so this method number one to me for so far is checking out good. This catalytic converter is working properly at this moment. Signals are showing normally. Upstream O2 sensor is switching from rich to lean. Downstream O2 sensor, which is a sensor after the catalytic converter, is working properly. Like I said, there's variables to this test. Things that could affect this fluctuation with the downstream O2 sensor. Number one could be a lazy or faulty O2 sensor that's starting to go out. Number two could be exhaust leaks in the upstream area of the system, which is before the catalytic converter. So any exhaust leaks that's before the catalytic converter will affect your voltage signal on the downstream O2 sensor, due to the fact that the O2 sensor is reading extra oxygen in the system. Alright, so method number one, so far the catalytic converter is checking out good. Alright, so the next method I'm going to use a infrared laser light and compare the temperatures from the inlet to the outlet of the exhaust system. I'm gonna pretty much compare the upstream temperature to the downstream O2 sensor, which is after the catalytic. Alright, so let me set up and then I'll show you the second method. Alright guys, so with the RPM set at 2000 RPMs, I'm going to perform the second method by using a infrared laser beam gun, and I'm going to compare the temperatures of the inlet to the outlet. The difference between the outlet to the inlet should be approximately 10% hotter than the inlet. 10% could be about 100 degrees Fahrenheit hotter than the inlet. So I'm gonna test the outlet first. I'm gonna point it to the outlet of the catalytic converter. I'm set to degrees Fahrenheit, and I'm set to max voltage. So here we go, guys. So the outlet is showing about 410 degrees Fahrenheit, So far the max has been about 414. I'm going to compare the inlet now, which is part of the upstream of the catalytic converter. I'm going to point the laser to the inlet. It's showing about 360, about 376. So it's fluctuating between 370, 380. Now it actually dropped. So far the inlet is showing about 350, 348. I'm going to compare the outlet once again. Our outlet is showing about close to 400 degrees Fahrenheit. This is not really that around that range of a 10% temperature difference. It's about close to 50 degrees difference. So this is about 5%. So that pretty much shows that the catalytic converter may be showing signs of actually going out. Like I said, this is a 2001. It's the original catalytic converter. So this catalytic converter has been in this vehicle for about 18 years. So I'm pretty sure it's about time for this catalytic converter to get replaced. From about 422. 423 being the max now. I'm going to go back to the inlet. It's around the 340 range. So now it's actually looking that now the difference is close to 100 now, to that 10% range. The difference right now is about 80 degrees. It's almost close to that difference of 100. So this is method number 2, which I use to diagnose this P0420. So far the catalytic is starting to show signs of going out, but still the outlet is still showing that it's harder than the inlet, which is still good. So now the method number 3, I'm going to actually use a back pressure tester, and I'm going to remove the downstream O2 sensor, which lives in the housing of the catalytic converter, which is actually in the other side of the catalytic. So that's going to be method number 3. I'm going to set up and then show you guys. Alright guys, so this is my my exhaust back pressure already installed at the downstream O2 sensor location, which lives in the middle of the catalytic converter. So now, let's go and perform this exhaust back pressure test. Alright guys, so this is my gauge already. The way this test works is that during a cranking, our PSI should be approximately 0 PSI. If it's not at 0 PSI when you crank the engine, that's pretty much an indication that the catalytic converter is restricted. And then once you crank the engine, the next step to it is to actually raise the RPM to 3000. The spec for 3000 RPM is basically no more than 2 PSI of back pressure. On a good catalytic converter, it should be less than 2 PSI. Alright guys, so the next step I'm going to do is to go and crank the engine and see what happens to this PSI during cranking. Alright guys, so this next step I'm going to perform, I'm going to raise the RPM to 3000, and our back pressure cannot exceed more than 2 psi, and if it does, that shows signs of a faulty cat going bad. But if it stays within 0 and 2 psi, that's pretty much a good indication that the catalytic converter is still in good condition. Alright. Alright guys, so after performing these 3 methods that I showed you guys by using a scan tool, an infrared laser gun, and a exhaust back pressure tester, pretty much all 3 methods show that the catalytic converter is still working properly, it's still working efficiently. I'm thinking this is an intermittent, where the computer triggers this P0420, or at times the catalytic converter is not working to its potential efficiency. You know, let's not forget this is a 18 years old original cat. You know, so there's probably a moment where this, you know, where the computer sees that the cat is not producing its potential. I'll say, you know, this is normal for an aging cat, but so far I'll say that the Muffler Shop, they diagnosed this vehicle, this cat, as a replacement. I'll say that this cat is still working properly, but you know, it's up to the customer if he wants to replace it or not. But this diagnosis, it still proves that the catalytic converter is still working to its efficiency. So hopefully these 3 methods works out for you guys who are dealing with these P0420 codes. So you know, so this is how I go about, you know, doing this diagnosis by using these 3 methods. All right, so this is Eli the OBD Tech. Subscribe if you like.